Formulas in 3 dimensions. Our objectives are to apply Euler's formula to find the number of vertices, edges, and faces of a polyhedron, as well as apply the distance and midpoint formulas in 3 dimensions. Why learn this? Well, divers can use a 3-dimensional coordinate system to find distances between 2 points underwater. Let's start with some vocabulary. A polyhedron is formed by 4 or more polygons that intersect only at their edges. Space is the set of all points in 3 dimensions. Notice these figures on the left are polyhedrons. The ones on the right are not polyhedrons. Well, Euler's formula. For any polyhedron with V vertices, E edges, and F faces, if you take the number of vertices, subtract the edges, and then add the number of faces, you will always get 2. If not, you've counted something wrong. Let's try it. Using Euler's formula, find the number of vertices, edges, and faces of each polyhedron. Use your results to verify Euler's formula. Well, vertices, we have 1, 2, 3, 4 vertices. We have 1, 2, 3, 4, 5, 6 edges, and 1 face, 2 faces, 3 faces, and 4 faces. So V minus 6 plus 4 is going to give you 2. Yeah. All right, well, let's try B. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. Then we have the 5 edges of this pentagon, the 5 edges of that pentagon. So we've got 10 plus 1, 2, 3, 4, 5. So 15 edges. And the faces, we have 1, 2, 3, 4, 5, 6, 7. So 10 minus 15 plus 7. Well, is that 2? Yes, it is. All right. Well, let's look at the diagonal of a right rectangular prism. So that's when you go from one corner of the box, in this case the upper left-hand corner in front, to the bottom right-hand corner in the back. So that's the diagonal of your figure here. Well, the formula you can use is D equals the square root of L squared plus W squared plus H squared. Let's try using it. Find the unknown dimension in each figure. The length of the diagonal of a 3-inch by 4-inch by 5-inch rectangular prism. Well, the formula said D equals the square root of L squared plus W squared plus H squared. So let's just fill in that information. So, L squared, W squared, H squared. And now we simplify. So 9, 16, and 25. Add those together. You're going to get the square root of 50, which is about 7.1 inches. So the length of the diagonal is about 7 1/10 inches. Take a moment and try this next one. Now that you've had a moment to try it, let's do it together. The height of a rectangular prism with an 8-foot by 12-foot base and an 18-foot diagonal. Well, in this one, they gave you the diagonal. So you're going to have your 18 equals the square root of, we've got 8 feet by 12 feet, so 8 squared plus 12 squared plus, and we don't know what the height is, so our height is going to be represented by a variable. Well, now we can simplify. 8 squared is 64. 12 squared is 144. We don't know what h squared is because that's what we're trying to figure out. So we've got 18 equals Well, to get rid of this square root here, we need to square both sides. So we're going to take 18 and square it. And then if we square this side, we'll get rid of the square root. So we'll just have 64 plus 144 plus h squared. So 18 squared is 324. And then we have 64 and 144, which makes 208. And then we just keep this plus h squared off to the side here. Alright, well we want to get h squared by itself, so we're going to subtract 208 from both sides, which leaves us with 116 equals h squared. Well, since h needs to be by itself, we're going to take the square root of both sides. So h equals the square root of 116, which is about 10.6 feet. Let's look at a three-dimensional coordinate plane. A three-dimensional coordinate system has three perpendicular axes: the x-axis, y-axis, and the z-axis. X, Y, Z. So instead of having an XY coordinate, now you just have an XYZ coordinate. Okay, your X goes forward and back. Your Y goes side to side, and your Z goes up and down. Think perspective. So, if you were to be given the point 3, 2, 4, well, step 1, go forward since your X is your 3, and that's forward and back. So you would come forward 3, and then kind of pause. Alright, so then we have a 2. That's when we go side to side, so left and right. Okay, well we need to go over what is about 2. So 1, 2-ish. Okay, and then we need to go up 4 since that's our Z. So from here, we're just going to go up about 4. And that is about where 3, 2, 4 is. You don't need to be 100% exact, but the closer you are to being 3, 2, and then 4, the easier it's going to be to draw three-dimensional figures inside of a coordinate plane. Noticing what a 3D coordinate system looks like might help you better understand the distance and midpoint formulas in 3 dimensions. So, for the distance formula, it almost looks exactly the same as in 2 dimensions, because you have the x2 minus x1, that quantity squared, plus the quantity y2 minus y1 squared. Well, to make it 3 dimensions, just add in the z, plus z2 minus z1, and then that quantity squared. So your distance formula is almost the same, you just kind of add in this little z part. The midpoint formula is the same. So you took the average of your x's and the average of your y's when you were finding the middle of a segment in 2 dimensions. Well, if it's in 3 dimensions, just take the average of your x's, y's, and z's, and then you'll have the middle of that segment. Let's try practicing. Find the distance between the given points. Find the midpoint of the segment with the given endpoints. Round to the nearest tenth if necessary. So take a moment and write down these 2 coordinates here. Now that you've had a moment to write down the 2 coordinates, let's try doing this one together. The distance equals, and then we have our, we'll label them here, so we've got x1, y1, z1, and then we have x2, y2, and z2. Alright, so our first one said x2 minus x1, so we're going to take that quantity, so 3 minus 0, and then we square it. And then we're going to add our y, so we have y, y2 minus y1, so we have 4 minus 0, and then we're going to square that one. And then for our z, we're going to have our 12 minus 0. So we have 12 minus 0. And we're going to square that one. And let's finish off our square root symbol there. Alright, so now let's simplify. 3 minus 0 is 3. 3 squared is 9. 4 minus 0 is 4. 4 squared is 16. And 12 minus 0 is 12. And 12 squared is 144. Still all underneath the square root. Alright, so now we have 9 plus 16 plus 144, which is the square root of 169. And if we take the square root of 169, we get 13. So the distance between 0, 0, 0 and 3, 4, 12 is 13 units. Alright, well, we also have to find the midpoint. So our midpoint stated that we should find the average of our x's, the average of our y's, and the average of our z's. So we'll have 3 plus 0 divided by 2, 4 plus 0 divided by 2, and 12 plus 0 divided by 2. And that will give us our middle coordinate. So we have 3 halves if we simplify this one. 4 divided by 2 is 2. And 12 divided by 2 is 6. So 3 halves, 2, and 6 would represent our midpoint. Try this next one on your own. Now that you've had a moment to try this on your own, let's do it together. So we have d equals the square root, and then we'll have 7 minus 3 squared plus 12 minus 8 squared plus 15 minus 10 squared, and that's all underneath the square root symbol here. So we have 7 minus 3 squared, which is going to be 16. 12 minus 8, that quantity squared, is going to give us 16. And then we have 15 minus 10, and that quantity squared is going to give us 25. So we have 16 plus 16 plus 25, which gives us the square root of 57, which is about 7.5. So the distance is about 7.5. Let's try the midpoint. So we're going to take the average of our x's, the average of our y's, and the average of our z's. Alright, so if we do 7 plus 3 and divide it by 2, we end up with 5. If we do 12 plus 8, divide that by 2, we end up with 10. And if we do 15 plus 10 and divide that by 2, we get 12.5. So there's our midpoint. That also concludes our lesson on formulas in 3 dimensions.